Alright, today I'm going to begin to talk about solving systems by substitution. It's just another method of solving systems. We could continue to use the graphing method, which we learned yesterday, but now we're going to use another method. This will actually give us the exact answer rather than having to guess where two lines intersect if they don't intersect at an exact whole number. So there's three things that can happen. Remember that you could have one solution if the lines intersect. You could have no solutions if you have parallel lines. When we have substitution and we have a no solution, it will turn out something like this, where we get an untrue statement, 10 equals 3 or 6 equals 7 or 8 equals 5. When that happens, we will go ahead and say that there is no solution. When you have the same line, you'll end up with an equation that says like 10 equals 10 or 0 equals 0 or 5 equals 5. So a true statement, and what we'll write for that is that there's infinitely many solutions. So we're going to get ready to talk about the steps for substitution. And what we're going to do when we solve using substitution is you're going to look for an equation that has either a variable with a coefficient of 1, or the variable or the equation could already be solved for y or x. That's the ideal situation, because if the equation's already solved for y or x, then we can just jump to step number 2. What that allows us to do is make a large substitution, and it'll give us an equation that has only one variable that we'll be able to solve, and then we'll take that answer and we'll plug that back in. So let's see how this works in this problem. This is the way I like to do this. I like to take the equation that has the variable all by itself and write it on this left-hand side. That is step number 2, to get an equation of x or y all by itself. Step number 3 is to actually substitute. Well, what are you substituting? Well, I'm going to replace y with what it's equal to. It's equal to 2x minus 4. So I'm going to take this box, that's what y equals this rectangle, and I'm going to put this rectangle in for y. So I'm going to rewrite everything that's there except that y I'm going to put a rectangle there for. So I'm making a substitution for y. And what I'm going to do, instead of writing y, I wrote this rectangle. Well, I'm going to fill in the rectangle with what it equals, 2x minus 4. So what this really says is it says I have 2x minus 2 times 2x minus 4 equals 8. Now what I can do is change my signs to plus the opposite, and I can distribute so I can solve for my x. So I get 2x plus negative 4x plus negative 2 times negative 4 is an 8 equals 8. Solve by combining like terms. Move the 8 over by subtracting 8. And then divide by negative 2. This gives me x is 0. The last step is to take this and plug this back in. Why are we doing that? Because we should get, if we're going to have a solution, it should be an x-y ordered pair. So I have the x part is 0. Where am I going to plug this back into is I like to do this whole circle type thing. So I'm going to take and plug that 0 back in up here. So I get 2 times 0 minus 4. So I replace my x with 0. That gives me y equals 0 minus 4. So I get y equals negative 4. Now, just like with the solving systems graphically, you can also check your solutions for systems. Or for substitution. If you want to know if this is right, you take the 0 and plug it in for x, you take the negative 4 and plug it in for y, and you see if it's true. This gives you 0 minus 4, which is negative 4. Now, if I plug in 0 for my x here and negative 4 for my y, I get 0, and this ends up being negative 2 times negative 4, which is a positive 8. So both of these are, 0, negative 4 works in both equations, so I can be assured that I have the correct answer.